First, you type your credentials into the login web page of the SGABU platform. After your successful login, the Stenosis cases dataset can be accessed via the cardiovascular disease modeling module in the main dashboard of the platform. A help file immediately opens that provides information about the dataset. You can access again the help file by left-clicking on the blue button with the white question mark on the top right of the page. This dataset contains 3 arterial cases with different degrees of stenosis, which are summarized as artery with 2% stenosis, artery with 79% stenosis, and artery with bifurcation. Upon clicking on any of the 3 scenarios, you observe the names of the geometries that constitute the artery and a table of 5 metrics with appropriate values that describe the artery. Namely, these metrics include the vessel length, the lesion vessel length, the reference vessel diameter, the minimum lumen diameter of the vessel, and the percentage diameter stenosis. For the case of the artery with 2% stenosis, the geometries include the inner surface of the arterial lumen and the outer surface of the artery, here presented as translated rotated inner and translated rotated outer, respectively. The geometries of translated ring 1 and translated ring 2 constitute the cross-section profiles of the end caps of the artery. Upon left-clicking, any geometry is visualized with the in-browser PowerView glance. Now, the geometry of the outer surface of the artery being selected is shown in the graphics window. On the left, there is a panel with settings that facilitate and control visualization of the object. The triple bar button on the top left controls the toggling of this panel. On the Datasets tab, with the representation options, you can control the type of visualization, being surface, surface with edges, wireframe, or points. With the mesh options, you can also change with the appropriate slide bar the point size of each node and the opacity of the object. With the colors options in the Datasets tab, you can change the color of the object. The settings of the Tools tab are used for the visualization of image datasets and are irrelevant for viewing an STL geometry. For viewing an STL geometry, some relevant options in the Global tab include the change of the background color and the options regarding the interaction style and the orientation axis. The interaction style options include the attributes default and first person. By choosing default, you can navigate in the graphics window through the following mouse actions. By left-clicking and holding the mouse button on any point in the graphics window, the user can rotate the object. By right-clicking and holding the mouse button on any point in the graphics window, the user can zoom in and out of the object. The same action can also be achieved by scrolling the middle mouse roller. By pressing Shift and left-click and holding the mouse button on any point in the graphics window, you can translate the object. The orientation axis settings include the type option of the triad being displayed either as arrows or cube in the graphics window, and the preset option, which displays the triad as an XYZ or an LPS coordinate system. Some useful options in the bottom right of the graphics window include to change background color, take a screenshot of the current view, split the view into 2 views and into 4 views. For the case of artery with 79% stenosis, the options offered look similar, because the only difference between the 2 scenarios is the severity of stenosis. For the case of artery with bifurcation, you will also observe an extra translated ring 3. In this case, there are 3 translated rings, because as you observe by opening the outer surface of the artery, you need 3 cross-section profiles to cap the geometry. This concludes the tutorial. Thank you.